So I'm going to click on this live, and here we are on the YouTube. Okay. So I hope we have studied in like previous class. What about the things about ray optics we have studied? No, in this Hyderabad region. Okay. Good afternoon. Okay, students. So here we go, and let us start a class. As you know, like. So I'm audible properly? Yes or no? Is my audio properly? I mean, it's fine. No noise, extra noises, background noises. Everything is fine. I hope. If it is okay, let us start the class. Okay. See, one of you must text me. Is if everything is fine, we'll start the class now. Yes or no? Yes or no? Yes or no? Okay. So Nilima says yes, sir. Fine. Okay, Nilima, that's great. Let me see how many students have joined yet. I've given you 5 extra minutes to join. So TA have joined, Abinja have joined, Nilima have joined, Ramadevi have joined, Lakshmi have joined, Gayatri have joined, this number have joined. Okay, cool. No issues. We'll still continue the class even if the students are less. Okay. You want me to change some background? Let us check different backgrounds. Let us choose a different virtual background. I don't have any here. I'll down someday. I will download someday again. Okay. Okay. So let us see the contents list now. If everything is okay. In the previous class, we have seen reflection of light. Okay. And also we practice some numericals. Okay. I have written a wrong spelling here. I must write it properly. It is C here. Practice numericals. Okay. Got it. So now we'll again start from this. Gayatri says yes, Nilma says yes. Cool. So now we'll again start from this. Okay. And also we'll see what we'll study in the contents. But before, let us do some revision here. Okay. So these were the laws of refraction, which we have studied in the previous class, isn't it, students? Yes or no? Yes, sir. So these were the laws of refraction. And you know what we studied about the laws of refraction specifically? We have studied this thing that, hold on. Okay, some students have texted me. Let me see that. What's that? Okay, you want me to start that recording too? No, that's fine. So we have studied the laws of refraction and such. We have seen this thing that the incident ray. Oh, what you are doing? Don't make noise. The incident ray, okay, and the normal to any refracting surface, not reflection. Oh, who is this person? See, I'll send you. I mean, I can. Mute yourself. Please, Supriya. Please, Supriya, mute yourself. So we have seen this thing, the incident ray. Okay. And the normal and the reflecting to any point on the incidence and the refracted ray all lie in the same plane. Okay. So you can see this thing. This N dash is what? Is basically normal to the refracting surface. Okay. This N dash is what? Is basically normal to the refracting surface. And what is this refracting surface? It's like this. Okay. And suppose the incident ray is what? Incident ray is this. And this is what? Refracted ray. Okay. Angle of incidence is this one. Refraction angle is this one. Angle of incidence is equals to angle of refraction. This is angle I and this is angle R. Okay. I means what? This is angle of incidence. R is the angle of refraction. So you can see they all lie in what? See, this law was followed in reflection, not in refraction. Remember, okay. So if you're putting this law here, it will be what? Sorry, it will be what? A big no for this. Okay. So here we are equating these angles in a certain kind of formula relationship, that is this. Let we say here that N1 is here refractive index is what? Refractive index of, or in medium 1, N2 is what? Refractive index in medium 2. Okay. And this was actually derived from the Snell's law, in which we have seen sine of the angle of incidence. Okay, see here carefully, watch. Sine of the angle of incidence, sine of the angle of R, okay, and 2 upon N1, V1 upon V2, lambda 1 upon lambda 2. Okay, this subscripts V1, V2, I mean V1 and 1 and 2 and 2, what are these? It means in the medium 1, the light speed, in the medium 1, the light's wavelength, because light is what? Like an electromagnetic wave. Okay. Similarly, N2, this is N1. Okay, so that's fine. It's opposite. Remember the relationships. Okay, these are some fast, like, things which we have seen in the previous class. Now we'll move fast towards the next topics. Okay, but before that, let us see a topic, a recall question. Students, yahan tak samajh mein aaya? Revision. It is, it's self-explanatory kind of slide. Okay, so it's self-explaining you. What are the things here? Is it right? Am I wrong or right? Yes, students. Any one of you? कोई तो reply करो. Anyone of you must reply here. Okay. Lakshmi, Nilima, Gayatri, anyone 8499264614. Anyone? Okay. So I hope that you understood it. Clear, sir. Okay, cool. Now let us see the question. Students, this is a recall question for you, because if we have at least revised some theory, so we must also have a question with that. Okay, because it, theory and application combinedly will give you a word, way or breakthrough this time. I mean, towards the main target, that is maybe NEET or IIT. Okay, because in IIT, what happens if you are cleared in the theory conceptually plus applications? If you're able to if you're able to apply those concepts in the theory, in the numericals applications, and that's the thing. Okay, I hope it's clear. So this is a very cool recall question for you. I will not be solving for you, because this is a recall question. So I'll give you a hint. Okay. The hint of this for the solution required, I mean the hint which is required for the solution of this question is this. You will use this formula, top slide here. And 2 upon N1, V1 upon V2. Okay. So you use like this, sine I upon sine R. Okay. And this is what? You will write here, was this? N2 upon N1. N2 upon N1. And next is what? V1 upon V2. Okay. V1 upon V2. Lambda 1 upon lambda 2. Got it, students? This is a hint for you. Apply this thing here and get the answer. I am waiting for 2 minutes for you. I'll give you 2 minutes for this. देखो इस question में है क्या? Let me explain. You only have to solve this question in the class. You can, okay? Don't think you're not able to solve. This much hint is enough for the solution of this question. It says like this: find the speed of light in medium A if the speed of light in medium B is c by 3. समझ में आया? What is this? Speed of light in medium A. Medium A. Speed of light कितना है? c by 3. ठीक है? Medium. Speed of light they're asking from you. Okay. Speed of light, find the speed of light in medium A if the speed of light in medium B is c by 3. So actually medium B में speed of light c by 3 दे रखा है. Please mute yourself. And medium A में speed we need to find. Let us mark it with V subscript A.
Class physics class.
Jyoti, please mute yourself. Kritika, please mute yourself. Kritika, Rajesh, PM, please mute yourself. I put the host off. Don't touch the settings there, okay? Okay, good. So these are the things. So this is the speed of light in medium B, matlab V2. This is the speed of light in medium A, matlab V1. Okay? And they've given the angle. So they have given basically Angle of incidence is 45 degree. And angle of refraction is 60 degree. Can't you apply these things? And find what? This VA. So you have to apply the particular combinations from numerator, denominator, one pair, numerator, denominator, other pair. So what you will apply? You will apply this thing, equate this thing with this thing. Because they are not asking refractive indices. They're asking what? They're asking there's a speed of light there. Apply this. All the parameters I've given you. Apply this and get the answer. I'm waiting for your answer. Students, I'm waiting for your answer. What do you think? What do you think? What will be your answer? Answer it. Any one of you. Solve it, students. I'm waiting for your answer. Okay. I'm giving you 2 minutes. Then I will solve it. I'll give you the solution. Then we'll start the new contents of today's class. Okay. So solve it. Give me the answer. All the parameters are in front of you. Equate this sin I 45, R 60. V1, how much? I don't know. V2, C by 3. Who is this, students? Anna, Elsa, Joy, what are you doing here? Please don't touch this screen like this. Okay. Okay, students, equate this thing. What this person had did, I don't know on the screen. Students, you are not allowed to do this thing in the class. Please remove this. Gayatri, can you remove this? Nilima or Gayatri, can you remove this thing from this? Okay. This red color mark from here. I'm not able to remove it. I don't know how it happened like this. Remove this thing from here. Okay, so let us proceed. Okay. Hold on. Let me do something. Just wait for a second. See, now don't do. Okay, please now don't do. At the last. Okay, so go ahead, answer. One of the students have given the answer. Now I think the slide is properly visible. Okay. So one of the students have given the answer. So the answer is this. That is, see, students, it's for you. This NGO is for what? I mean, you know, we are teaching here for what? For your well-being. No. If you don't want to attend the class, you want to do this thing, you can leave it. Okay. Got it. If you don't want to study, you're not forced. But at least let other students join, like, start the class. I mean, let other students be, because they are, well passionate for cracking the exams. So if you don't want to study, you can don't irritate the class in between. Okay. Next, from the next time, I will put the settings off. Okay. So that's not good. You know this thing. These are not good manners. We are grown up. So now let us see the answers. Okay. I'm writing the answers here. No need of saying sorry. Okay. I mean, the thing is this. So don't touch the screen in which I'm like writing on the PPT, because it creates a lot of problem here. Okay. So the question was this. I will be just solving here. Okay. Nilima has given answer. Very good, Nilima. Excellent. Okay. Very good. Sin I mean not sin. It's sin I. Sin R equals to what is this? V1 upon V2. We know the speeds. V2 is C by 3. Okay, right here V2 is equals to C by 3. V1 we need to finally take it as Y. Sine I angle is equals to what? 45 degree. So it is sine 45 1 by root 2. Sine R is equals to what? 60 degrees. Sine 60 is root 3 by 2. Okay, let us solve this thing. Y upon C by 3, 1 by root 2, root 3 by 2. Okay, root 3 by 2. So when you will solve this thing, what comes? It is equals to C by 3 multiply by 1 by root 2, 2 by root 3. And the answer is C 2 root 2 upon 3 root 3 y. It means this is y is equals to what we have assumed v1. So we'll say here v1 speed to 3 root 2 by 3. Got it? So this is the speed of light in the medium wave. Speed of medium. Which kind of medium? I mean medium A here. Okay, students, got it? Yes or no? This is the speed of light in medium A. Very good, very good. So this speed is clear for you all people. And now, next thing. This answer is clear. This solution is clear. Yes or no? Yes. Okay. Now, students, let us proceed for the contents of this. So this is today's class contents, by the way, students. Okay, all of you, all the students here. So first we'll go with the numericals. Okay, numericals we have already seen. We'll see the apparent normal shift, a new topic. My voice is audible? No. I hope the voice is audible to you. I hope the voice is clear. Okay. So let us go towards this apparent depth and normal shift. Let us go towards apparent depth and normal shift. Now clear. Okay, cool. Apparent depth and normal shift. So what is this apparent depth and normal shift, students? What is this apparent depth and normal shift? Let us see. Okay, it's clear already. Please, students, don't irritate the class. From Jane, students from Jane Chitradurga, please mute yourself. Mute yourself. Students from Jane Chitradurga, mute yourself. Okay, good. See, what we are able to see here is this. But if we are standing on the top, we'll be able to see that fish is here. We'll see what? We'll see fish is here, which is it's basically apparent depth. Similarly, for this box, depth is this much. This is the actual depth, the real depth. We can consider this as what? Actual or equal to real depth. Okay. And this is what? This is the apparent or fake depth. This is apparent depth or fake depth. Okay, this much. Okay, got it. The above is the air which is having mu equals to 1, and this is the water which is having mu equals to how much? How much? What is about the mu of the water? Anyone? It's 4 by 3. 1.33, no. It's 1.33. 1.5 is for glass. Okay. So mu here for air is 1, mu for water is equals to 1.33. Okay. So now let us observe this thing, that this one was the real depth, okay, which was greater than this apparent depth. So this is the phenomenon of this, that is the thing which is actually, which is at an actual depth is appearing to you as at what, somewhat above. The reason is what? Reason is this rays. If you observe the rays here, students, see, suppose this fish. So let me highlight the thing. Yellow color is fine. Okay. See, this fish is here. This ray is going from this fish, and when it meets at this boundary, at this point, the boundary which is separating the medium of the water and the medium of the air, it is getting refracted, है ना, like this. And when it is extended back, it meets here, which give you a fake image, and that is the apparent depth. Okay, what's the reason? Let us go behind the science now. What's the reason? The reason is this, students. This is the normal to this medium. Okay. So we'll say like this. This is the angle of incidence. Okay. Of course, when a ray of light passes from we know this thing in the refraction. When a ray of light passes from a denser medium to rarer medium, what happens? When a ray of light passes from a denser medium to rarer medium, what happens? It refracts away from the normal, away from the normal. Okay. So when it is passing from this to this, it is reflecting away from the normal. So this is R here. So I will say R is greater than I angle. Okay, R is greater than I angle. Okay, and when this ray is extended back, it will meet here. This will give you what? The real depth. Sorry, apparent depth, which is a fake one. Similar phenomenon will use here. You can see here that this box is actually here. You know, the ray going from here, there's an angle of incidence. So when the ray of light passes from a more denser medium to a ray, it what? It refracts, okay, it deviates away from the normal because it is going in the rarer medium. So this is R. Again, R is greater than I. Right? So when it is extended back, virtual image you will find here. A image which is a kind of virtual race, you know. It's suppose it is coming from that kind of image, a virtual thing. But it is to your eye that you will appear like it will appear like this. The object is here, which is a fake depth. Now we'll see the mathematical formulation behind this. But first of all, text me. Is this thing clear? What's the reason of this apparent depth? What is, I mean, what's the reason of this shifting of this object's height? Reason is the process of reflection. Okay, ये reflection के कारण ही हो रहा है. This is happening due to reflection. Remember. Now let us see the mathematical formulation of this. Got it? First of all, text me before the next slide. Did you understood this all the things? Yes or no? All the students are important, you know. Anjana, Number, Manja, Akshya, Anusha, Baimi, Gayatri, and all the students. Okay, from JNV West Godavari, you have joined Chitra Durga, Jyotisha, Lakshmi. Okay, so all the students are important. Each and every student is important. We want from all of you students to, you know what, reach in the best of the best colleges. Okay, as hard work you can do as much as you can. Is this clear? Refraction process. This slide is clear. Understood? समझ में आ गया? Got it. Very good. Very good. Okay, students, now let us see the mathematical formulation. Now I'm going to show you here. Just relax back and watch this on the screen. What is happening? So mathematical formulation is this, students. See, this is the object here. This is what? Object. Okay. Rays are going like this. Okay. This is normal. This is normal to this boundary. This is normal to this boundary separating two mediums. This is normal to this boundary separating two mediums. Okay. And this medium is what? This medium, say this is water. Let us suppose this is water denser. Okay. This is water denser, or you can say any denser medium. Of course, one is denser. Above will be what? Of course, this will be rarer medium. ये क्या होगा? ये rarer होगा. Suppose air or like you can make the combinations. No, I've given you the values, students. What do you do? See, this oil is having the refractive index 1.5. Okay, and this is oil. Next thing is what? Water is having refractive index as 1.33. Next is what? Air is having refractive index is equals to what? 1, 1.33, 1.5. N equals to 1.5, 1.33, and n equals to 1 here. Okay, got it? So now let us see how to solve it, how to mathematically formulate the things, okay, and find the real depth and apparent depth, okay. Students will not be going into the derivation, no required, so chill, okay. Derivation, not required, so chill, okay. Just remember the formulas. Suppose the object's real depth is this, I'm showing you. This is what? This D is what? Its real depth, the actual depth. Students, this is the actual depth of the object. This is the actual depth of this O object. Okay. And this is what, when the rays goes like this, you know, the process of refraction will occur when the ray passes from a denser medium to a rarer medium. It deviates away from the normal. Okay. And when extended back, it will show you the object's like position, like it's actually a fake image. I mean, that's fake thing, we know, but it will show you this, the ray when extended back, it will meet here. So this will show you the image of the object, which is actually fake. We know the object is here. So this D dash, which is from, see, distances are measured from the boundary only. Remember this thing. This D dash is what? It's a fake apparent depth. Okay. So this I will write is like what? Fake depth. You see the proper words, the physical significance word, like no physics word is this apparent depth. समझ में आ गया? This much thing is cleared. Now remember, one universal formula for this is this. That is, this is the universal formula. Let me use the yellow color. This, students. Got it? That is N2 upon N1 D dash upon D. Okay. This is what? N2 upon N1 N2 upon N1 D dash upon D. N2 upon N1 D upon D. This is the formula for, I hope I'm audible. I'm audible, no? Okay, ये formula याद रखना students. It's very important formula for you people. So this will give you the relation. This gives you what? Relation between refractive indexes of what? N2 matlab kitna? N2 is what? If you see the screen, N2 is the rarer medium. I'm writing here. For you here, when the object is inside the denser medium, N2 is for rarer. See, more proper word is rarer medium. N1 is the denser medium. And these are the same things. D dash is apparent, D is real depth. Okay. And this is some important notes. What are the important notes? Okay. The above formula is value is only valid for paraxial rays. Okay. And distances should be taken from the surface. Okay. And N2 is the refractive index of the medium where rays going in, and N1 is from where the rays coming. Got this thing, students? Okay. देख लो ना, N2 is the refractive index of the medium where the ray is going. You can see this thing. This is N2, refractive index of the medium where the ray is going. Okay. And N1 is what? From where the ray is coming. This is the object rays coming from this. So now I'll apply this formula in the application. Okay, let us see the application properly. Let us focus here, students, on the application. Okay. I'll solve this question, the first part and the second part. If you are not able to understand the theory, no issues. ये formula लिख लिया था ना? Have you noted down this formula? Note it down. So this gives the relation between the refractive indices of the rarer and the denser medium and the apparent depth and the real depth. Note down these things. I'm waiting for a few seconds. Okay? Okay. Now let us see this question. So focus here carefully. If you're focused here when I'm like explaining this question, if you understood it, it's clear. So now you'll be able to solve all the kinds of questions which are basically symmetric to this. Not same, symmetric. Okay? Somewhat same. In the kind of formulation of this question. So yes, ready? Cool. कैसे करें इस question को? Which color you want? Blue. So it says apparent distance of the fish. First, question, the first part of this question, A and B, two parts are there. The apparent distance of the fish from the surface as observed by the bird. Apparent distance of the fish from the surface as observed by the bird. वो कितना है? Apparent distance fish का which is observed from the surface, like from the surface observed by the bird, कितना हो? See, we know this thing. The real depth is how much given here. If you observe this thing, the real depth is 36 centimeter. Real depth is 36 centimeter. Okay, this is what? Real depth 36 centimeter. Okay, and apparent depth is how much? Apparent, this is the real depth. Okay, apparent distance we need to find. Huh? So I mean, suppose fish is here. So suppose students, if the ray is going like this, okay, suppose bird's eye is here. This is the bird's eye. Okay, suppose this is the bird's eye. Okay, so this is incidence angle. We know this thing. When the ray goes from the denser mediums, the water is what? Denser, 4/3, and air is what? Air or vacuum is what? Rarer medium. Huh? Mu equals to 1. So when the ray of light goes from a denser medium to a rarer medium, what happens? It deviates away from the normal. So this will be the deviation. So suppose the eyes is this, it will reach here, R angle. Okay, when it's somewhat tilted, okay, let me show it properly. Hold on. So it's somewhat tilted like this. Okay. So when it's extended back, it will meet here. Okay. So we'll say like this, this will be the fish. Okay. This is the apparent depth D dash of the fish. Okay. Actually, look, actual location of fish is this. But to our eyes, when this ray is extended back, to the bird's eye, it will appear like this. Bird को क्या लगेगा? Bird को ऐसे लगेगा कि the fish is here. Okay, this is the D dash. So they're asking from us to find D dash. What it will be? Simple. Use the formula. So what's the formula? Formula is this: rarer upon denser. Okay, apply it. I'll say like, see, picture is in front of you. Okay, picture is available. So we'll say rarer upon denser, 1/4/3 equals to rarer में है मतलब air में मतलब it will appear to us fake apparent depth, which is here marked with apparent depth, which is here marked with D dash. नीचे क्या है? It is real depth, which is here marked with D. Okay, so 1/4/3 D dash upon D. D कितना होगा? D we know it is always measure the distances from this surface. D is equals to 36. Okay, right here 36. Okay, we get what answer now? We get D dash is equals to 36 3/4. 27. This is the answer. So we'll get this value that D dash, which is basically what kind of depth? कैसी depth है students see? Apparent depth is equals to 27 centimeter. So first answer is 27. C, fish का actual depth कितना है? 36 centimeter from this layer. Okay, but from this layer the apparent depth is 27. So it's less than 36. We know it will be above. अब bird को कैसे लगेगा? What will be the bird's what is the distance of this fish, the fake image from this bird? वो कितना होगा? What is equals to that? How much? We'll add this 36, the height of the bird, which is with which this bird is flying above this layer separating two mediums. 36 plus the remaining fake depth 27. This will give you the complete answer. So 36 plus 27 is how much, students? 363 centimeter. Okay, this is the first answer. Got it? Did you got the answer? So note it down. Note it down now, students. We'll get like this: 27 plus 36 equals to 63 centimeters. Okay. Is this question clear? Yes or no? Okay. Now let us see the next question, B part. Now it is asking the reverse thing. That is, if fish is observing the bird, so what will be the apparent distance of the bird from the surface observed by the fish? Now this is the question. वो कितना होगा? It's opposite now. Okay. So let us see this thing also. So for this, I'll reverse the formula. I just have to reverse the mediums. Okay. So I will say like this now. So since, okay, let me draw the complete diagram here. This is a surface separating two mediums. This is what? Water. Okay. And the bird is flying above. This is suppose bird is there. Okay. So now with respect to fish, they're asking from us. Okay. Suppose the rays are coming like this, and this is a normal incidence angle. We know this thing. When the ray passes from a rarer medium to denser medium, it deviates towards the normal. Okay, I have to make somewhat big angle here. So see it carefully. This is angle of incidence. When the ray passes from a rarer medium to denser medium, it deviates towards the normal. So it will be towards the normal, such that angle of refraction will be what? Greater or less? Less than angle of incidence. Hai got it? It is reverse of the previous case. And suppose the fish is lying here. Fish की आई तो यहाँ है ना? Fish is here actually. Okay. So fish will see like this, that if I extend these rays back, I'll get the location of the bird such that it is here, which is the apparent location, students. This is we know this thing. This is the apparent point of the location of this bird. Apparent location. So fish को क्या लगेगा? Fish will see that the bird is there or far away. Okay. One observation we have to do, just hold on. And we know this thing in practical, practical may naturally, originality in genuine. This is the bird's real location. Got it? So now they're asking from you this thing, that is this. This is the, see, always you have to measure a distance from the boundary separating two mediums. Remember this. This is for water. This is for air. This is the real height of the bird. Okay. And this is the real height, and that is what? This is actually, this complete, if I take, is the fake height. देखो इसमें there is some change in the previous case and this case. In this, the fake height is greater than the actual one. This is fake or apparent height or distance or magnitude is greater than the real one. But if you see back slides, we know this thing. In this, what is the thing? We know this thing. Here you can see in this. Okay, let us take this case. Very easy. Here we can see this thing, that apparent depth marked with D dash, real depth D. We can see here apparent depth is less than the actual depth. Okay, we can see here D is greater than D dash. दिख रहा है ना ये? This is D dash. Okay, got it? This is what? D dash. D is greater than D dash. We know this, है ना? D is greater. So actual here is greater than apparent. But when we see from the top, as the mediums are different, if you're from the denser, you will follow this case. Okay, if you're in the rarer, as the case of the second part, that is the birds, when the fish is observing. Okay, so when you are in the denser medium, the case will change. If you're in the rarer medium, the case will be previous. Okay, so now you can see in this what is happening. D dash is greater than D. So they're asking the value of this D dash now. Again, kuch nahi karna, you have to just interchange the mediums, refractive indices. You have to just interchange the refractive indexes of the medium individually. Okay, so it's like this now. Initially kitna tha? N2 upon N1. Okay, so we were writing there N2 was for, you can see this thing, N2 was for what? Kahan formula? Rarer medium, hai na? Now change this thing. So we'll change because the medium is changed. Now we are solving this question with respect to what? Fish. Initially we were solving this question with respect to birds. That's why the fish was above. It was appearing to eyes, that is, it is somewhat like up in height. But now it's, this bird is appearing far away to this fish. So इसके लिए हम लिखेंगे, initially we're writing 1, now we're writing 4/3. Now we'll write this. It's changed. Rest of the things will be same. D dash upon D. D dash, D is how much? From the surface, it is, original depth is how much, students? 36 only. See the question. 36. Okay? You are able to see, no? 36 is the original depth. Write it here. Sorry, for the bird we need. No. Bird ke liye kitna hai original depth? Same 36 for the bird also. Okay. Yes. So from the fish perspective, we are saying we'll get like this, that the image of the bird is here and this image of the bird is here, and this d dash is the big one and d is this, which is equals to 36. So now we'll solve for this. You'll get the answer as how much equals to 48 centimeters. Got it? And it matches the physical significance which we have found it out, extracted out, is what? That apparent location is at d dash, which is greater than d. And you can see this thing here, d dash is 48 and original was how much? Bird's key location from that medium separating, it was 36. If you want to see from the fish level, okay, so you can add what? 36 in that. Okay, so you can add here 36 and fish ka yahan se kitna tha? 36 plus. Add them. You'll get again, you'll get the same different, I mean the values which are greater in, I mean you will get the value, isme ye d dash will be always greater than d. Got it? If you see the previous values, this is not the case. Isme 63 centimeter, no, this not, this 27 centimeter, okay. Isme 27 centimeter is the high depth and actually is how much? 36. So this is less. Okay, I mean you can see this d dash is less than d, or d is greater than d dash. Lekin isme what's the thing? Isme d dash is greater than d. Remember all this. Okay, now I hope you understood this thing. Is it clear? Yes or no, students? Is this solution clear or not? Text me so we can move towards the next. Your solution clear hai ya nahi? No, you can note it down. Answers are these two. These two are the answers, students. Very good, very good. Okay, thank you. So it's clear, that's good, you know. Now let us move towards the next thing, which is a new theory topic, this. Okay. See, students. Hold on, let me see where's the video. See it carefully. Suppose you're having an object. You're having an object here. Okay. Okay, let us assume like this. Suppose you are watching an aquarium. You are seeing an aquarium. You know, we can find the aquarium in the schools also. Maybe, you know, we keep in the home also. You know, somewhere you'll find in the homes, somewhere you'll find in the schools, somewhere if you go in the real show, like, you know, museum kind of thing, aquarium, you can see that a big aquarium there. You can see the fishes here and there. You know, suppose you are seeing a box kind of aquarium. Okay, suppose this is the surface of that box. Okay, and this box surface line, suppose it is behaving like a boundary which is separating two mediums. It's behaving like a boundary. Okay, students. Okay, good. All the students, you're texting yes, that's fine. Suppose this is behaving like a boundary which is separating two mediums, that is N1 and N2. Okay, so let us treat this thing. Suppose N1 is water. For sake of convenience, for understanding the concept, okay, let us treat this to be water. Water matlab pani, matlab water H2O, okay, denser medium. In physics, we say it as denser medium. Suppose this is N2, this we say as rarer medium. Okay, this is the object here. Okay, so suppose the ray is passing from the object like this, down, and it reaches here at this point. This is the angle of incidence of this ray, which it is making with this normal to this reflecting surface. We know this thing, when this ray will go out, it will deviate away from the normal. The reason is what? Because we have studied this concept, sir, in refraction, that whenever the ray is passing from a more denser medium to a rarer medium, it refracts, it deviates away from the normal. समझ में आ गया? It deviates away from the normal. Again, when you extend it back, it will reach here. We know this will be the image, which is the fake. ये हमने पहले पढ़ चुके हैं. We have studied this thing. Okay, this is the apparent depth. Okay, apparent distance you can call. AD matlab apparent, not that AD history. No, apparent distance is equals to Y here. Okay, you know this thing. And this is the real distance, RD, not RD Sharma mathematics. Okay. So, and we knew the formula, we have seen a formula for this, because this V basically Y basically stands for apparent depth and X basically stands for the real depth. Okay. Now suppose, students, if you're watching a fish and the fish is coming towards you, it's not just about the static object. Static matlab ruka hua, stopped. stuck there. It's not about the static object. It's about a thing, a object, or a fish, the natural living thing, which is coming. See, if fish is in a static condition, you will see its fake image, one thing, apparent distance. But if the fish is also moving, so we'll say with the fish, which is this O, this image will also move. So if someone is asking from you, find the velocity in such a case when the object is moving, okay, of the image, which is you actually know it is a fake thing. Okay, image is fake here. It's not the real, real picture is not that, it is X. How you'll find? So for this formula is defined, that is velocity of image with respect to the surface of refraction, and velocity of object with respect to this surface of refraction. Okay, n2 upon n1, where n2 is what? N2 is the location where your eye is, where you're observing, and n1 in this case is the object's medium. Got it? इसको derive कैसे किया है? Simple, they have used this first equation, they have done some modification, they have sent this x there. So when you will differentiate both sides with respect to t, okay, you'll get like this dy by dt. Dy by dt is how much, students? Dy by dt is how much? And this is dx by dt. How much is the dy by dt? Anyone? It is what basically? It is the velocity of, you will treat always as like we are standing on this refractive boundary. I mean, this is the boundary which is separating two mediums. So always treat it to be what? Like we are measuring the velocities with respect to, assuming we are on this boundary. It's not moving. Okay. So I will highlight here this velocity of fake image. I mean, the apparent location, or say y apparent image with respect to surface, and 2 upon n1, because you know how it's very easy to differentiate this. It's not a big rocket science kind of thing. Velocity of dx means what? Velocity of real depth of the object with respect to surface. Okay, got it? So this is the formula here. I hope you understood the formula. Okay? Is it okay, students? Are you able to? Now let us proceed towards solving the question. You must go or not? You must go for solving the question, and this will be the last question of today's class. Okay, I'll end the class after that. I hope you enjoyed the session. See, enjoying means, you must be able to understand the theory, concepts, and must be able to apply those theory and concepts in solving the numericals. Simple. If this goal is achieved, your class is, today's time is worth. It was successful. Mission complete. Okay, so let us solve this question. Gauri says yes, Jyotisha says okay, cool. So let us solve this question. So this is the question. Again, similar looking question from the previous slide. If you watch, this is a similar looking question from the previous slide. But here what is happening? Here, this is the bird. It is moving down with 24 centimeters per second. It is not now static. So we'll get the apparent locations also as per the view. If you're watching the bird, if you are on the bird, I mean, it's like this key. If you want to see the image of the fish, apparent depth with respect to bird, it will be up. If you want to see the bird's location when you're in the water, I mean, with respect to fish eye, it will be far away. Got it? These things are cleared from the back questions, previous questions. But what happens if the bird or the fish and this surface is also moving? First thing, will sit on the surface. We know the formula. Velocity of image or object. Velocity of image with respect to surface. Okay, n2 upon n1. N2 was for what? I there. Okay, it means n2 means for, you will write here for rarer, bird here. N1 is for denser. Okay, velocity of object, fish. Okay, with respect to surface. Got it, students? Yes or no? Okay. Now let us apply this thing. Apparent speed of the fish. So I will solve one question. Next question is a homework for you. This question I'm giving you as a homework. Okay. So at least let me tell you how to solve first question. You'll get an idea. ठीक? Apply the formulas. Okay, simple. So कैसे करना है? I'm going to show you here. Velocity of image with respect to surface n2 upon n1. Velocity of object with respect to surface. Velocity of image minus velocity of surface n2 upon n1. Velocity of object minus velocity of surface. ठीक है? Image क्या होगा students? What is the image? Image speed. So it's given here. These are the figures. Okay, they're asking the apparent speed of the fish as observed by the bird. So suppose image is somewhat here. You know this thing. This will happen. This will be the image of the fish. So this will be also moving with some speed, say Vf. Okay. So we'll put it as Vf vector. Okay, let us put it as Vf vector. We know the original speed of the fish is what? 12 centimeter per second. This is the original speed of the fish. And V1 is the refracting surface boundary speed. Write these values. So Vf minus Vs. Take upward to be positive. This is positive. This is negative. Down is negative. So minus of plus 1 centimeter per second. Minus, we have studied this concept in kinematics, relative velocity concept. If V vector A respect to B means what? Velocity of A with respect to ground minus velocity of B with respect to ground. You can drop this with respect to ground things, and I can write directly here VA minus VB. Finish. I'm going to end the class now. Last point. Students, just wait. Last point. Minus 1 equals to N2. N2 is the rarer medium. That is air. N1 is the denser water, 4/3. Object speed. Object is what? Fish, because we are observing the fish. First part is what? Apparent speed of the fish. Velocity. Apparent speed मतलब fish की जो image है, the speed, the velocity of the image of the fish they're asking from us. As with perception, I mean with respect to bird. Okay. So bird is moving like this. It's not required. Fish is object here. Object यहाँ पे क्या है? First part में fish है. Next part में bird होगा. ठीक है? Hint. So fish की speed कितनी है? Plus 12 centimeter per second, right? This 12 centimeter per second. Minus again surface, it's 1 only. Solve this, we get the answer. ये 3/4 हो जाएगा. 3/4 means how much? 3/4 into 12 minus 3/4. 4 3 ja. So this will give you what value? Actually, this will give you the value equals to 3/4 11. Okay. 3/4 11. Vf minus 1. If we'll add these things plus 1, this will give equals to 33 plus 4 or upon 4 plus 1. This will give the velocity of fish with respect to ground, by the way. Okay, you can treat it like velocity of fish as we are observing from the external condition. I mean, our feet are on the ground. Okay, it's like this. Let me raise this thing. So velocity of fish, right? Here simple, the velocity of fish. What is the answer? 33 plus 4 upon 4. क्या आएगा आंसर? What is the answer? 4 5 6 4 33 34 35 36 37. Okay, simple, no? 37/4 centimeter per second is the answer. So we'll say if the object, that is here fish, is moving with, which is the fish basically, is moving with 12 centimeter per second up, then this its image, fish का जो image होगा, it will be moving with 37/4 centimeter per second. Let us see, is it like what? It's greater or same? I mean, what kind of? Greater or less? Divide karo. It's less. Okay. Okay, it's 9 point something centimeter per second. Very good, Jyotisha, very good. So students, conclusion is this, that apparent depth is what thing that it's actually the image depth when we are observing it from the above as shown by these two pictures. Got it? And we can conclude one more thing. It's almost based on where you are. If you're in the rarer medium, you will see that the object is towards you. If you are looking from the denser medium, that is the fish eye, with respect to fish eye, okay, you will observe that the bird is far away. So this was the conclusion. And the speed you can see yourself. Next part will be when you will solve of this question. Okay, this question, next part, tell me the speed which comes, apparent speed of the fish. The bird will be at the back, it's far away. Uska speed kitna aega? Is it less or greater than the original 24 centimeter per second? This is your homework. This question, second part, I will take as a recall by explaining the revision part initially. I mean, in the next class. Okay, got it? So that was all about today's class, students. Thank you so much for your attendance. Be happy, study well. If you're having any doubts, you can text on my personal number or you can text here in the Zoom also. Okay, got it? Fine. Bye bye everyone. Bye Nirima. Bye Jyotisha. Bye everyone. Take care. Be study happy well. Okay, I'm ending the class. Bye bye YouTube students. Bye bye. Bye bye everyone. We'll meet in the next class. Bye everyone. Okay, bye
Thank you,
Jyotisha.
sir.
Bye bye. Yes. Okay. We can leave the class.